Our next speaker this morning is Tim Walters. Tim is currently a vice president and one of the founders of Pinnacle Wireless, a nationwide system integration firm. Tim has over 25 years in the wireless communications business. He was also one of the founding partners of Integrated Dispatch Solutions, whose product, Mindshare, is a leading IP dispatch product. Tim has significant experience in the land mobile radio marketplace, implementing large-scale, complex technology projects. Pinnacle Wireless is a North American distributor for products designed and manufactured by Cellex Communications. Please welcome Tim here this morning.
Morning. Okay, I'm going to talk to you about a Simulcast DMR project that I implemented in New England for utility. It's a multi-phase project, so a couple of things that we had with the customer that we're trying to solve we'll go through here. They lacked enough frequencies to implement a system that would cover all of their territory. And they were currently operating on VHF, low band, and UHF channels. So we decided to try to move them to UHF. And the only way to implement the coverage was to design a simulcast system. We got the extra capacity by implementing DMR as a technology, giving them the extra time slots and the extra bandwidth they needed. So with the requirement to have multiple sites and multiple coverage zones, the only practical solution that we could come up with was to create a simulcast system. They absolutely had to have voted audio, and so as I was looking around trying to figure out how to find a solution that was going to meet their needs, I became aware of Cellex Communications, and they're headquartered out of Italy, but have a very, very sophisticated product that provides receiver-voted audio. They needed to implement some enhanced DMR features like GPS location. They wanted to have telephone interconnect on their system. They wanted to do text messaging and some enhanced services, and so the feature sets of DMR were the right solution. They really had been operating on multiple bands and multiple different channels in a conventional architecture, single site. So they were always trying to find their users as they moved from zone to zone, from site coverage to site coverage, so it was problematic for them to locate their people. They wanted to eventually migrate to portable coverage, so the system was designed and architected for mobile coverage. They needed site diagnostics and SNMP alarming to determine if there were issues at any of the sites. They're a self-maintained customer, but they have very few resources to go out and service the equipment. So SNMP alarming was a key feature for them. And obviously, the narrowband requirement was pressing on them, so this was a key objective of the system design. They wanted a proven technology. They were very risk averse. They didn't want to take any risks in being a pilot for something that hadn't been proven. So Cellex Communications has been building since 1970 simulcast product, and they installed the first DMR simulcast system in 2008. The client did go over to Italy and visit existing customers, existing utilities, to see the system operating and in use, and that gave them a significant comfort level that the product that they were going to put in was the right solution. So the first phase of the project was 5 radio sites. It's a conventional architecture, not trunked, UHF, 110 watt amplifier, 48 volt. It's all connected via IP. We designed the system for 4 RF channels. We installed 3 and sized everything to slide an extra chassis in if they wanted to expand the system. So there's there's forward capability to grow. They wanted to use the DMR features, so they wanted to use it in the digital mode. Approximately 200 users and mobile coverage design. The system was installed and completed in the fall of last year, and it's operational and functional now. Here's a little bit of an overview of the architecture. So you can see this is the master site here. It's 3 RF channels. Everything is backhauled via microwave. This was a legacy Ceragon system that they had in place. They have a T1 that goes out to one site that's being serviced by Verizon. All of this is interconnected via IP. They've got a logging recorder, the RBX, which is a Telvio product for telephone interconnect, as well as they have SNMP management with a tool that's part of what Celex supplies. It's called Cinetic. All of this is connected to PBX, and as well as their dispatch console system. And this is their Sonnet network. So this is phase 1 of the project, just one area of the system, and we're in the process of expanding the system to another 12 sites and 6 channels. So it's going to get a lot bigger. So one of the major components is the Celex RBS 4000. We're choosing to use IP connectivity, but the station can be equipped to have 4-wire E&M, E1, T1, or fiber optic, as well as RF to connect those stations into the system. There's a second station that's called an RNFE. It's a radio network front end. This is the interface to get your audio off the network. It does the vocoding for the DMR, so you can get an output from that to feed any kind of a legacy console that you might have in place. The system was designed with Motorola turbo radios, mobiles and portables in the architecture. We also implemented pyramid in-vehicle repeaters for the system to provide them coverage with their portables for lone workers, as well as they did not have any man-down functions in their network, so that was a key feature for them that we rolled out as well. And we integrated all of this into a system management server, logging recorder, telephone interconnect server, and we implemented StreetTrack software to provide the GPS location information and their man-down functions into their dispatch network. It's a picture of the station, and everything in the station is contained in a single chassis. All the synchronization, equalization, and voting all take place in that single chassis. There's no external timing. There's a GPS receiver that gets connected, but all of the functionality of the Simulcast network takes place in the single station. The architecture of the system is such that you can have a master station. All of the audio flows back and forth to the master station. All the voting takes place at the master station, and the timing and equalization all are coordinated through the master station. The nesting process is you can have submasters that can take over in case the master fails, and you can have slaves that sit out on the end of the system that just respond to the submasters. So very flexible architecture to create redundancy and system resiliency. The single station performs all these synchronization, equalization tasks, as well as the voting. It's a modular design, so it's a 2 RU card cage. There's a core module in there with an IP interface that really does all of the, is really the brains. And then you can add interface cards, power module, power amplifier, and transmit and receive card. Very easy to expand the system to add in additional base stations. And the network management portion makes the network maintenance very, very simple. You can see the whole network from a single station and look at every single card and module on the network and see its performance and how it's functioning. We used Motorola radios and put in the portable radios, which they're going to use for telephone interconnect. We installed an option board in those for the telephone interconnect function. The client has implemented phase 2 now, so 2 more regions are coming online, and the system's getting expanded. They had different RF frequencies in one region. We were using 484 channels for 6 sites, and in the other region we're using 451 channels. So they're slightly different RF frequencies, but the system is designed to simulcast in zones, not as a single simulcast system. They're going to be adding some telemetry applications to do remote management of some of the devices in the network. They want to expand portable coverage, so adding in-building amplifiers. We did have a little bit of a learning curve with the client on the end users on the audio. It did sound different. They were not used to the digital sound, so that lasted for probably 3 or 4 weeks, and now they all seem to think it sounds great. We had this project is fairly large, and we're rolling it out in multiple phases. So we put the subscriber units into the customer's vehicles in an analog mode and on their legacy channels. And when we made the migration, we had multiple iterations of programming that got changed. So it was one of those things you don't know that you can avoid it at all. You know you're going to reprogram radios, but more care, probably setting up those mobiles initially, really thinking those things through would be a recommendation, but you're going to have to reprogram a few times. It just seems inevitable. We had some innovations. There was a legacy console system from IDS Mindshare system. It's an IP console, and we had to develop a console gateway to take the audio off the RNFE and then feed it to their dispatch network. They run 2 redundant centers that are 100 miles apart, so both centers needed access, and we achieved that through a gateway design. This is the gateway that goes in to feed the console system as well as the Cinetic. All that comes off the RNFE. We have the product here in the trade show if you want to come over and take a look at it. If you have any further questions, I can answer them then. Thank you.
Thank you.